Hi guys, what's up? I want to go over some of the stuff that we're talking about in the work energy chapters. All your information, you should, at this point, hopefully you've completed all of lesson one, basic terminology and concepts. We're talking about work and power. Looking at the how work and energy are related and power. I really like the physics classroom explanations. They're very thorough and they did really well. I like how they identify the big ideas here. And then have these interactions. Please, please, please engage in the interactions. I highly recommend you like set up a table in your homework and kind of write down your answers. Or I went over with one of you, like they kind of went through and started their answers, like, okay, hey, I don't get it. That's the perfect thing for us to be going over in our meetings. Okay, there you go. Work through these. So for example, I'll work these through with you. Teacher applies a force on a wall and becomes exhausted. Does this represent an example of work? Work, when a force acts upon an object to cause displacement, it is said that work is done. Note the key word displacement. If I push on a wall for 25 minutes, not only am I, well, stupid, but I haven't done any displacement. I have not moved at all. So the answer is no. This is not an example of work. Okay, the next one. Book falls off a table and it free falls. Well, just because there's no appearance of work, like no one's throwing it at the ground, but the fact that like where is the force coming from? Earth is actually applying a force on it, right? So there's your F. And the displacement, it moves from one height to another. That is a displacement, so F times D. And then the angle is 90 degrees, right? So cosine 90. Okay. A waiter carries a tray full of meals above his head by one arm, that is, and he walks straight across the room at a constant speed. Okay. A waiter carries a full tray of meals above his head by one arm, straight across the room at a constant speed. So the answer here is no. There is a force, the waiter pushing up on the tray, and the displacement is the tray moving horizontally. Yet the force is not what's causing the displacement. So the explanation here is like, here's my arm. It's applying what we call a normal force on an object, right? There's my phone. Now, my displacement is in this direction. This force, the normal force from my hand applying on the phone, is not causing my displacement. Okay, so just because I'm moving, like I would have to be pushing, like if I were pushing, if you guys have seen me around campus, I have my nerdy little cart. Me pushing the cart across. Like if a busser is pulling a cart full of like dishes across the restaurant, that's one thing. But holding the act of holding up the tray, once they say it's at a constant place, that's not an example of work. If I did this, I displaced the tray. But because the force arrow isn't, the movement of the force isn't the same as the force applied to the tray, it's not considered. We can go over that more if you would like. And a rocket accelerating through space, because the rocket is accelerating, there is a force applied and it's going through space. There's a displacement. So yes, this is an example of work. Okay, should have read through all of these. Here's the equation we're using. I'm telling you, you must show your work using a lined sheet of paper or a notebook, and I must be able to read it and see it. That's how I'm grading the work. I must, like, you're going to hold it up to the screen and I'm going to go make sure you've actually done it. Yes, I do know this does have answers on it. I expect you to be going through it. And like one of the young men I'm working with, we discussed those answers. Okay. So you read through the material and then it suggests it's an all uphill interactive. Go through and read through most of these of Unit 1 and then we're going to do the uphill activity. So I'm going to click on that now. And I want to walk you through how I expect you to do this. If you haven't figured it out yet, I need you to look now. There's an interactive component and there's an activity. The activity, the best way to deal with this actually, if you have a program called OneNote, so OneNote is the purple icon in Microsoft. Most computers come with it. If it doesn't, then we'll have to figure something else out. But if you have a school computer and they left all the major content on it, then you should be good. OneNote, what's cool is rather than downloading, I can just hit print and I can choose the option send to OneNote and it'll send it right over. And that's kind of what I did here. So if you take a look here, sent it to OneNote. What's nice about OneNote is it just makes it an image that you can write all over. Okay, I don't know why I did that. So I can double click right here. Say I want my text to go right here, right? Okay. You can really click anywhere and type all over the document. So there's that. Next thing I want you to look at, read through the directions, and then we have your table. What I would expect you to do in order to be able to graph this content is take this table and put it into an Excel spreadsheet. So you can see I tried to do this once before, and okay, I put the angles in. To get the decimal places over 1, I chose this. This increases the decimal place. I made up these forces. These forces are not accurate given the interaction, so please do not copy my data. I will know that you didn't try the activity. The displacement, I have no idea what the displacement is. That's on you. Put in your own data. And then work. You have to solve for work. Work is force times distance times cosine theta. And I'm sure you could probably use sine and cosine in an Excel spreadsheet. Like you could probably type it in. I'm not sure. I haven't gotten to that level of math with my freshmen. Okay, so I opened up a calculator called Desmos, and they have access to a scientific calculator. So you can do your calculations here and it will calculate it. Try and make your material scientifically accurate, like scientific notation slash significant figures. So the shortest significant figure is 1, so you should probably stick with 11, I would say. Technically, that's 2 significant figures, so there's that. So once you put your data in, you're going to put it in your Excel spreadsheet, type in your numbers. I'm going to make up some numbers just for time. Okay, I'll say 2, 3, 4, 5, 6, 7, 8. Okay, now let's talk about some graphing. Okay, first one we're going to do is we're going to graph this. Insert, and just choose recommended charts, and I pick this line graph. Notice it does your big numbers on the side and your forces on the y-axis. Please label your chart well with a descriptive title that's multiple word phrase or sentence. Then add chart elements, axis title, the primary horizontal in this case is angle, and then primary vertical is force. Now the reason why I really like OneNote, so you notice it printed into here, the reason why I like it is because now I can take all the work I did, and this is a terrible graph. If you copy this graph into your OneNote and turn it in, we're going to have a problem. But I'm going to copy it because I'm being lazy and quick, and I only get 15 minutes to explain, and paste it right here. Look at that. Now the next one, go back to Excel. This one gets a little more complicated. I select angle. Now I hold down the Control key, and I select the work. I'm going to choose Insert, Recommended Charts. I'm going to pick this liney looking one again. Notice it follows that same path. I made a nice even graph. I don't think that's correct. Again, I'm adding my chart elements, and you're going to label them accurately. And then I'm going to take this, I'm going to copy it and put it into OneNote right there. Maybe make it bigger so I can actually read it. You'll answer your following questions and write a conclusion. You can do it over the side or on the bottom, however you want to do it. And then to turn this guy in, you're going to choose File, Export, File Export or File Print. And nope. Okay, you're gonna have to export it. File, export to a PDF. There you go. You export it and you'll turn that guy in. So that is something you can turn in without showing me visually on the computer. So that's how you do this interactive. This is a good way to do all the labs that we have because a lot of them are going to come from the physics classroom or from the PhET simulation website. If this doesn't work, do it in a Word document and copy your graphs over. Okay, so hopefully that helped. You should be working through all kinds of data. I think your next lab will be out of PhET. So check that out, explore, keep working through your energy material. So we're working through all of this, the energy. You'll be moving on to work energy relationships next. Okay, have a great night. Please, please, please contact me. Shoot me messages, whatever. Just make sure you're connecting with me and we're getting our hours. Either like I'm counting some of your hours as the things you watch. So I teach, so 11 minutes right here, 12, maybe 14 by the time I'm done rambling. And I'm counting the time we meet together face to face via whatever method you've chosen. Right. Thanks, guys.